Hello guys, in this series of videos I'm going to teach you guys how I managed to create a recommendation engine even though I had almost zero knowledge of it. So basically I'm working at a very small company, and in startups and small companies you sometimes get tasks that are very irrelevant and unknown to you at first, of course. Like, for example, I knew front-end development and a little bit of back-end development and database management before, but I didn't know anything about AI and machine learning. So all of a sudden, I just received this task for a recommendation engine. I was supposed to recommend to the users some of the items on the database which are related to the items they had already added. It was actually skills. So, for example, if you add this skill, say, for example, web development, skills such as web design are supposed to be recommended to you on that specific page. So it was actually a pretty interesting challenge, and I at the point I didn't know anything about AI and machine learning, and honestly, even right now, I still don't know too much about it. I'm still really trying hard to learn more and more every day. So let's just go through this and see how it's going to work out. So first, we're going to import our libraries for the API for the recommendation engine. Yes, we're going to actually do it in Python, and we're going to use NumPy, sklearn, and pandas to basically get our recommendation engine to work. And later on, we're going to use Flask to actually create an API for this in order to basically create the bridge between our API, our Python app, and basically I'm actually going to do it in Laravel. So we're going to make a bridge between our Laravel web application and our Python recommendation engine, so that these two can constantly communicate with each other. So yeah, let's get to it. Import pandas as PD, import numpy as np. So yeah, we're going to import sklearn, and from sklearn.decomposition, we're going to import truncated svd. Yeah, there we go. So yeah, by the way, we're using Jupyter Notebook to demonstrate how our data science part of the task is working. So Jupyter makes it very clear to demonstrate how the process of basically managing our data and getting to the endpoint works. So I would highly recommend that. And if you start with Jupyter and then go to the IDE and then just implement the final product in your IDE, such as VS Code. So let's do this. Let's get on the decomposition. Okay, all right. So first of all, I want you guys to download from this link, which I'm going to put in the description, the data that we're going to be using. So we are going to need lots of data about the movies that are out there. So this has 100,000 movie ratings, and it's quite public. You can just download it from this link. And basically, this has like a lot of data about what users rated over the past few years. So, for example, how many users rated this movie, and did those same users rate other movies as well? So the way our recommendation engine is going to work is based on user preferences. So if this user has given like a rating of 9 to Star Wars, and also a rating of 9 to, say, Die Hard, then these two movies are going to be similar. They're gonna be similar because the same user has chosen both movies and it's given a 9 to them. So it's all about the user ratings and what they have given to those specific movies. And from this, we're going to create a correlation matrix, which I'm going to explain to you guys later on, which shows how each movie is related to the other movie based on the user ratings. So it's actually pretty interesting. So just follow along. After downloading this, if we go to the folder and open this up, we can see the u.data file. If we open this up with something such as Notepad, we're going to see what looks like gibberish, but it actually isn't. So the first one is user ID. The second one is the movie ID, which we're going to call item ID. And the third one is the rating each user gave to that movie. The fourth one doesn't really matter. So let's just create this array called columns is equal to user ID, item ID, let's call it movie ID, rating, what's the other one? Timestamp, doesn't really matter. And the last one is a timestamp, which is telling us at what time did the user give this rating. And then over here, we're going to be using that data. So read CSV. What's happening? Okay. pd.read CSV. This folder u.data. And what we're going to do is we're going to give it the names is equal to columns. Let's call this our user data. And now let's just see how the first 5 rows on the user data are going to look. So if you don't know much about Panda's functions, head is going to show the first 5 rows of the data frame that you've actually come up with. So it says user ID is this, movie ID. Oh, yeah. So actually, we're going to have to use a separator as a tab. Let's define it as, let's put it at the end. Okay. Let's just put this guy at the end. We're going to use a separator, call it tab, because as you can see, each item has been separated by a tab. So let's try this now. And yeah, boom. User ID now 196, movie ID this, rating, timestamp, and beautiful. So what we're going to do next is we're going to require the movie data. What genre does each movie have, and things like that. So now we're going to go for the movies data. So let's define this variable called movie data as pd.read CSV ml u.item, and the separator for this one I believe is going to be no, the other one, u.item. Yeah, it's gonna be, well, this character. So separator is equal to this, and let's run this. The error is, oh, it's not a UTF-8 encoding, so we're gonna change the encoding to Latin 1 for this file. And let's see the first 5 rows. Okay, so yeah, we are actually gonna have to name the rest of these, but maybe not for now. These are actually the genres for each movie. Is it a musical? Is it a horror movie? Is it a romance? Whatever. And so what we're actually gonna care about is just the name of the movie and its ID. Yeah, that's it. The rest we don't care about. However, we are going to have to actually define the heads. Basically, we're going to have to define a header for this file. So for that to happen, we're going to have to. You can just copy this array because this is an array of 24 elements, and I wouldn't want you guys to just type all these. The first one is item ID, movie title, release date, video release date, IMDb URL, unknown, I don't know what this one is, and then the genres come after. So yeah, and then we're gonna use this as a names on this pd.read CSV. Names is equal to columns, Let's try this, and yeah, now it looks much more interesting. Item ID, movie title, release date, video release date, and all the rest. So now we have the data for our users, we have the data for our movies, and now what we're going to do is we're going to merge these two data. So you're going to go merge on what point? On the item ID, right? So actually, yeah, let's call this movie ID. It's going to make it easier for our merging process. Let's run this. By the way I run this is by pressing Control and Enter. So you can try that as well. Let's go. Merge data is equal to, so we're going to merge these two tables together, is equal to pd.merge, I love pandas, user data, wait, user data, movie data on what? We're going to merge them on movie ID. And let's find this. All right, so now we got our merge data. As you can see, we can now see that what each user has rated what movie, and we can also see a lot of other basically columns for each movie. So for example, this user ID, the ID 196 has given the ID 242, this rating at this timestamp, and the movie title is this. And we can later on see that, for example, there could be oh, okay. So as you can see, there's so many ratings for each movie. Let's say instead of that, instead of like 5, let's just show you guys 15 items, 15 rows, basically. So as you can see, this movie, Kolia, released in 1996, with this ID, is actually it has a lot of ratings. It's got ratings from all sorts of users. And then later on, we're going to use this basically quality of our data to create a correlation matrix. Very interesting. So, moving on. Alright, so the next step is to basically create a pivot table. You won't understand what I'm talking about until you see it. So, merged data. By the way, if you click tab, it's going to show you the suggested code that you're, for example, if you type in merged and then hit tab, it's going to show you guys merged data. You don't have to like type everything all by yourself. Just use the suggestions. Suggestions are really good. Merge data dot pivot table. Yes, that's the function we're looking for. The index, the index is going to be equal to user ID. The values are going to be equal to, yeah, the values is equal to what? It's going to be the rating. The course is equal to movie, what was this called? Movie title with a space. And we're gonna fill value, it's gonna be 0. So what's the fill value? It's gonna fill whatever null it finds with 0. Having null is terrible when it comes to data. So whenever you see a null in your data, you have to either fill it with something or you have to delete that row or column altogether. Depends on what you need. Let's see what we're gonna get. Alright, so yeah, as I was saying, you wouldn't understand until I showed you, and here I am showing you. The pivot table that we're talking about is gonna look something like this. So the movie title is gonna be like this. They're gonna be represented as the columns of our new table, and the user ID, the user IDs are going to be our rows. They're going to start our rows. So these are going to be our IDs, starting from 1, 2, 3, 4, 5, whatever. And then now we can see that what each user has rated each movie. So we can see that the user with ID 1 has not given any ratings to this movie, yeah, just these 2 movies. And then to this movie, it's given a 2. And then to this movie, a 3, a 4, and 5, a 3. So we're just going to figure out what each user has given each movie. Later on, we're really going to need this, so just be careful. Alright, so now we're going to want to transpose the data that we got over here. By transposing, we mean basically flipping the rows and columns so that our movie titles are going to basically be in the rows, and our user ratings are going to be the columns of our new data. So we're going to transpose it. That's what it's called. Let's create a new one. Yeah, by the way, if you click B, it's going to create a new cell at the bottom of this current cell that you've selected. So we're going to delete this. Too many. Yeah. Let's call this transposed data is equal to what do we call this? Data pivot table. Data pivot table dot values dot t, which is going to give us the transposed matrix. Now let's just check out the shape of our transposed matrix. Transposed data dot shape. Alright, as we can see here, we have a 1664 by 943 matrix over here. Now, 943 user ratings is going to be very difficult for our algorithm to basically create a correlation matrix for. So the less variables that we have, the better. So right now what we're going to do is we're going to consolidate our 943 user ratings into only 12. 12 is a good number, but the more than the number, the more accurate our algorithm is going to be. So let me just show you so you will understand. If we create a new cell over here, now we're going to use the SVD algorithm that we have required over here. Yeah, this sklearn truncated SVD. Now you'll see how we're going to use it actually. So let's define the SVD variable and say it's equal to truncated SVD with n components of 12, as we said before. So we're just going to consolidate all 943 users into 12. And now we're going to fit it to our data, to our transposed matrix data. We're going to say resultant matrix is equal to basically svd dot fit transform of our transposed data. Now let's see what the shape of our resultant matrix is. So as we guess, the what we guess is it's definitely going to be 1664 by 12 because that's what we are actually looking for, right? So that's our guess. We guess it's going to be 1664 by 12 matrix. So let's see, and we're right. It's 1664 by 12. So it actually consolidated it into only 12 users. It helps imagining it easier when we say it's just only 12 users, which basically represent our whole data, our whole community of users who've rated all these movies. Alright, so now find the correlation matrix that we've been talking about so long. So, yeah, basically a correlation matrix tells us what each movie means to another movie. So, for example, if it's like Star Wars, it means something to another Star Wars movie, meaning it's like really related to that movie, but it's probably not that related to, say, Batman or something, right? Or it could be, who knows? But like basically what a correlation matrix tells us is how each movie is related to all other movies. So right now we have 1664 movies. So each movie is related somehow to the other 1663 movies. So we are probably going to guess that our matrix is going to be a 1664 by 1664 matrix, right? Because each movie has some sort of relation to the other movies, right? So let's see what's going to happen. Over here, we're going to define the correlation matrix as numpy.corrcof of the resultant matrix, all right? So that's how we define the correlation matrix for this basically matrix, which is the resultant matrix. So, and then over here, we're going to see the shape of it and see if it's actually a 1664 by 1664 matrix. Shape. There we go. It's actually a 1664 by 1664 matrix. Yeah, I'm kind of getting tired of saying this. But yeah. Looks pretty cool, huh? All right, so now, for the sake of simplicity, we're gonna get our movie names. Everything's almost done, but just give me a few more minutes. Movie names is equal to, let's go back to our previous data set over here. So actually, we have all the movie names over here as columns of this data pivot table, right? So each column is a movie title. Till There Was You, 1900, 101 Dalmatians. So we're basically just going to get the columns, right? So let's just copy this. Sorry. Is equal to this dot columns, right? And let's see how it's going to look. Names. And it's going to look something like this, right? But I think it would look a lot better if it were represented as a list. So let's say movie list is equal to list of movie names. And now let's take a look at the movie list and see what we have on the list. All right, Till There Was You and all the other movies. All right, so in order to look up a movie, a specific movie in our correlation matrix that we just figured out, we're gonna have to get its index. Why? Because let me show you. If we're gonna say correlation matrix of say Till There Was You, this is not gonna work because it's just the way it is. We have to give it an integer. For example, 2. So if we give it 2, it's gonna give us all the numbers for the second movie, actually third movie because it's programming, which is probably gonna be. Ooh, I think I just printed all these. Not a good idea, guys. Don't overdo this. Let me just run this cell again because, oh, there we go. Yeah, the second movie in this table is, yeah, 101 Dalmatians, the third movie, yeah. So, yeah, this is going to be the number, the correlation value for that. So, we're going to have to find the integer. And how do we find the integer for each of these movie titles? By finding its index in this list, which we just figured out, right? In this movie names list. So let's actually go with the Dalmatians. Dalmatians is equal to movie names of, no, Dalmatians. I'm gonna stick with Dalmatians. 101 Dalmatians. Alright. And now let's see if Dalmatians is gonna look like, oh, sorry. Movie name dot index. Nope. I think I'm gonna have to use the parentheses instead of this. Movie names dot index, or is it the movie list dot index? Oh, sorry guys. Yeah, for a second I got really confused. Yeah, movie list dot index 101 Dalmatians 1996, and it's gonna give us the index. So say if I use this movie instead, All Things Fair. Yeah, 48. So now easily we're gonna get the index. This is gonna be really useful for us when it comes to the API. So just bear with me for now. Now, what we're going to do is we're going to find the correlation value for the Dalmatians movie. Let's say correlation matrix of Dalmatian. There we go. So we got the number, all these 1664 numbers, which basically form the row that is in the correlation matrix. Yeah, basically it is what it is. I know it sounds a little confusing, but if you actually review what I just said about the correlation matrix, it kind of makes sense, right? So you look up that row in this matrix, which belongs to the Dalmatians movie, and then you get listed all these like single values, which represent how this movie, the 101 Dalmatians, is related to all other movies. Okay, so to give you an example, if this number that you see over here, like the bigger this number, the more related this number is, this movie is to that movie. So if it's a 1, then it is definitely not 1 actually. Let's say if it's like 0.95, then it's really close to that movie. Based on the user ratings, it's like a really related movie, which we can actually use in our recommendation engine to recommend to the users. So kind of makes sense to do it that way. And yeah, so that's how we get the correlation metrics for the Dalmatians. Now it is going to be very simple if you want to find the movies that are like really related to the Dalmatians movie, huh? Let's see how it's going to happen. So create a new cell and list movie names where uh, okay, let's actually call this a variable. Dalmatians core is equal to this. Run it. Dalmatians core, oops, is bigger than 0.9 and it's less than 1. See how this is going to work. We use an AND over here, and it's less than 1. It says invalid syntax. Oh, okay. Looks like there really isn't any movie, which is like this. Let's say 0.7. Come on, yeah. So apparently there's really no movie that is that related to the Dalmatians movie. There's no movie that has a correlation amount of more than 0.9. But apparently there are a few that are between zero point 0.7 and between zero point 0.7 and 1. So Big Blue, Four Weddings, and a Funeral, all these movies. So based on the user ratings, these movies are really related to this movie. Yeah, congratulations. You just figured out how to find related movies to each movie. Yeah. Let's see what's gonna happen in the next movies, huh?